Next we see how we represent the number of elements in a set. If we have a set A here written where the elements are 1, 3, 5, 7 and 9, then the number of elements in set A is written as, we write it as n of A. Okay, when we write n of A, it means that this is number of elements in set A. Now the number of elements in set A are 1, 2, 3, 4 and 5. We have 5 elements here. So n of A is equal to 5. Now when we want to write the number of elements in the union of two sets A and B, it is written as n of A union B, which represents number of elements in this set of A union B. So similarly, if I have to write the number of elements in the intersection of two sets A and B, it is written as n of A intersection B. Now let us see what is the relationship between the number of elements in the union of sets A and B and the number of elements in the intersection of sets A and B. This number of elements in the union of sets A and B is n of A union B, and the number of elements in the intersection of sets A and B is n of A intersection B. So the relation is given here, that is n of A union B is equal to n of A plus n of B minus n of A intersection B. That is, if I want to know what are the number of elements in this set A union B, I will add the number of elements in set A, add the number of elements to the number of elements in set B, and I will subtract the number of elements in the intersection of the two sets A and B. Now here I have set A having the elements 3, 5, 7, 9 and 11. We are taking an example and seeing whether this statement holds good. Okay, B we have here is 3, 5, 9 and 13. Now look at n of A. It will be the number of elements in set A, that is 1, 2, 3, 4 and 5. So I write here n of A is equal to 5. N of B is the number of elements in set B. Therefore it is 1, 2, 3, 4. So I write here 4. Then I have n of A intersection B. A intersection B will include the elements which are common to both A and B. We see 3 is common to both set A and B. 5 also is common to both set A and B. We also see that 9 is common to both set A and B. That means we have 3 elements which are common to both. Therefore, n of A intersection B will be 3. If it is A intersection B, we have to write the set. N of A intersection B means number of elements in A intersection B, that is 3 elements are common to both these sets, so we write it as 3. Now let us see whether from these 3 we find out what is n of A union B. First let us put the elements in this Venn diagram. Okay, first we see which are the common elements. 3, 5 and 9 are the common elements which are present both in set A and set B. Therefore, they will be present here in this overlapping region, that is 3, 5 and 9. So, what is this? Actually, this region represents A intersection B, and this full one will represent A union B. So this is A intersection B. Now if 3, 5 and 9 are already written in A, what is left? 7 and 11. So I write here the elements 7 and 11. In set B, if 3, 5 and 9 are already written, what is the element which is left? That is 13. So I have written 13. Now when I see here A union B, it will have the elements 1, 7, 11, 3, 5, 9 and 13. Okay, so if I count these elements in n of A union B, how many will they be? 1, 2, 3, 4, 5 and 6. That means n of A union B is equal to 6. Let us now put these values which we have got in this and see if we get n of A union B is 6. N of A is 5. So I can write here in place of n of A 5 plus n of B. N of B is 4. Then I have minus n of A intersection B. N of A intersection B is 3. So minus 3. 5 plus 4 is 9. So this is 9 minus this 3. And 9 minus 3 is 6. So n of A union B is 6, and we had counted just now and said that the number of elements in A union B is equal to 6. So you see in this full Venn diagram, if we count the elements, it is 6, and we have confirmed with this relationship also which is given to us, that is n of A union B equal to n of A plus n of B minus n of A intersection B, that n of A union B will be 6.